Well, folks, back. There's a little bit of a change here. Hadn't seen the missus in a while, and when I showed up looking like a mountain man, she's like, I don't know that guy, so it's gone. But I want to do a quick overview of a complete motor control system with the power circuit and the control circuit and how they get connected. And I'll probably do another one on the interoperability or the interconnection between the two of what controls what in each circuit, which is what's going to help you in your troubleshooting process. Okay. If you guys will notice, I have the blue up here is your control circuit. Typically in the industry nowadays, 24 volt DC is what's being used. It's slowly being phased out. 120 volt AC used to be very common. Manufacturing facility I work in right now, I would say 90% of our machines are 120. 120 is a little more dangerous to work with. 24 volt DC, very forgiving, both on the equipment and on the individual. Down here in black is your three-phase power system. I've got things labeled here for you. You got 480 volts AC, 24 volts DC. So here's your leg 1, 2, and 3. This is your disconnect for your power, your fuses for your main power coming in, your motor contactor contacts, your overloads, and the three-phase squirrel cage motor here. Then we have our transformer. The H1 and H2 are labeled for your high side. Or the primary side, and it's 480 volts is what they're pulling off of this, and they're stepping that down to 120 volt AC. Your secondary side is X terminals, X1, X2, and then your X2 is grounded. This provides your neutral side for your 120 volt circuit. Okay, this next one here is your power supply. It takes 120 volt AC in, and its output is 24 volt DC. This is the positive side. And this is the negative side, which is typically, when you look inside the cabinet, it'll be listed as 0 volts DC. The previous video, we talked about a basic latching circuit. Your emergency stop, which is a push and maintain off. It has typically two deliberate processes to get that to return back into the on position. This is a normally closed push button, momentary switch. So when you push that, it breaks it. And as soon as you take your finger off, it returns back to its normal state. This is the push button normally open. When you push it, it maintains the contact. As soon as you release it, it returns back to its normal state. Here's your latch, set of contacts, normally open set of contacts. Here's the coil, which is represented by your terminal numbers A1 and A2, and here's your overload set of contacts, which are 95, 96. Okay, so this is the basic control circuit. This is the power circuit. This is what I like to refer to as the midget riding the Clydesdale. The Clydesdale is the big horse that's doing all the work, 480 volts, and depending on how that circuit is set up and what the overcurrent protection is and what size piece of equipment they're running, this is where the heavy current is being worked on. Okay, low voltage. So the midget doesn't have to do the heavy manual labor that this thing here is doing. It tells this what to do. Okay. If you have any questions on this, please make comments down in the bottom. If you know somebody who's struggling with motor controls, and how they work, pass this along to them. Thank you.